Hi guys, today we're going to look at bearings, but the type of bearings that we're going to look at is what we call three-figure bearing. There are other types of bearing that you should note, but the one that is common for both internal and external exams is the three-figure bearing. Okay. So now we're not going to waste much of your time. We'll proceed. Like I said, the concentration is on the three-figure bearing. So we're going to look at what we call the three-figure bearing. Now, before we can proceed, I think it is imperative for us to define what a bearing is. Now, by definition, a bearing, so I can write it for you. A bearing is an angle. Bearing is an angle that is measured clockwise. That is measured clockwise from the north. So bearing is an angle that is measured clockwise from the north. Now, what are the key words here? The key words is clockwise and north. So the bearing should move in a clockwise direction and it should come from the north. Those are the key words you should note. Then the other thing you should note is that we are interested in a three-figured bearing. For instance, how can you pronounce this angle? How can you write this angle as a bearing? For instance, let me give you an example. Let's say we have 62 degrees. Now 62 degrees as a three-figure bearing. This one is going to be 0, 62 degrees. So it's supposed to be three figures. So you put a 0 if the figures are not amounting to 3, so that it becomes 0, 62 degrees. All right. So now, but if you have angles which are already three figures, for instance, if you have 225 degrees as a bearing, it will maintain as 225 degrees. Then the other thing you should note is when you have decimals. I'll give you an example. Suppose you have a decimal angle that is, so suppose you have 224 then 0.6 degrees. Now this is to four significant figures, so as a three-figured bearing you round it up so that it becomes 225 degrees. Right. Then if you have something like 46.2 degrees, this one becomes, so when you round this one off, it becomes 46, so it becomes 0.46 degrees. So that is how you can go about it. So these are examples of the three-figured bearing. Now we're going to proceed. We'll go into questions, but before I can start looking at questions from past examination papers, I'm going to look at one important part that you should note every time you're looking at this point of bearings. and that is angles. So you should be familiar with angles. So we're going to look at just a small part of angles, not as an entire topic. So look at a small part on angles, and we see how best we can go about that. Now, what should you know about angles? Number one, the first thing you should know about angles is what we call angles on a straight line. So angles on a straight line. So that's the first thing you should note. Angles on a straight line, they are always equal to 180 degrees. So angles on a straight line are equal to 180 degrees. Second thing, you should also know about a complete circle. So a complete circle is equal to 360 degrees. So a complete circle is equal to 360 degrees. Then apart from that, the other thing you should know is what we call a right angle. So a right angle is equivalent to 90 degrees. So once you see a right angle, that one is equivalent to 90 degrees. The other type of angles that you should be familiar with, right? So we say angles in a triangle. So let's look at angles in a triangle. Now, the angles in a triangle, they should add up to, so we say they should sum to 180 degrees. If you add all the angles in a triangle, they should sum to 180 degrees. What do we mean? So I'll give you these scenarios. So we have this first type of a triangle that we can call as a scaling. Now a scaling triangle has all the sides different and the angles are different. We have x, y, and z. If you add all these angles, they'll add up to 180. We also have another type of triangle that we call an isosceles triangle. Now this isosceles triangle has got two angles. These two angles are the same and the sides are equal as well. So if this is x and this one is also x, this is the angle that is different. So such type of a triangle, we call it an isosceles triangle. The last type of a triangle that we have is a triangle that we call an equilateral triangle, and it has all the sides equal and all the angles are the same, meaning they are 60 degrees each. So such type of a triangle is known as an equilateral triangle. Very important for you to note. The other part you should know is this part. So suppose we have something like this, still on angles. Suppose we have something like this, like that, like that, like that. Suppose this is 140 degrees. Now this angle here and this angle here will be the same because these are called vertically opposite angles. This will also be 140. Then this is a straight line. Angles on a straight line, they add up to 180. So 180 minus 140 is 40. This is also a straight line. So 180 minus 140, this will equally be 40 degrees. From there, we're going to have this angle here and this angle will be the same. So we have 40 here. This is a straight line. We have 140 here. Then also we can get this as a straight line like this. we have 140 here. Then from there now we can say this angle and this angle are the same because they are vertically opposite, like that. Now the last part now that I want you to know is that will be very helpful on bearings is suppose we have an arrowhead like that and another arrowhead like that. This angle and this angle are going, these two angles, if this is x, this is y, so when we say x plus y, this should give us 180 degrees. So those should give us 180 degrees. So that is what you're supposed to know about angles. Now that you have ideas about angles, we're going to proceed to the topic of discussion, which is bearings. And in this topic we're going to start straight into looking at examples. We can do maybe 2 or 3 examples, then I give you some questions to try, just like that. Okay, so now here is the first example. Suppose you are given this. So the first example, let's say we have such a diagram. So we have an arrowhead like that, then we have something like that, then we have something like that, then this one is going that side, then we have something like that. Right, so now from there I can say let's say we have C here. We can say this is C, then we can say this is B, then if I say this is A, then now let me start putting the angles. So if I say there is an angle here of 35 degrees, then there is another angle here of 141 degrees, then we can put one last one here. There is another angle here, from there going like that. This angle is with 225 degrees. So those are the angles that we have. Then now what is the question? The question now is saying find, the question is saying find the bearing. This is a question on bearing. So find the bearing of the first one, we find the bearing of A from B. The second part, we find the bearing of A from C. Right, so now what we're going to do, I'll be using a different color to do the working out. Okay, so now this is what we're going to do. So basically, when you're given such kind of a question to find the bearing of A from B, you go where it's saying from. So we start at B, so go where B is found. So this is where B is, and ensure that the north is already there, because we said bearings, they move one in the clockwise direction and they move from the north pole. So the north is already there. This is a north and this is also a north, but the north at B is there. So the bearing should move from the north of B all the way up to the line that is joining A. So now look at, from here the bearing move like that all the way up to the line that is joining A, like that. Now if you observe, I was moving in the clockwise direction and never in the anti-clockwise. So now The question is that what is the angle that I have just created there. Now look at, I already have a 225 here. How do I find this other angle? Now to find the other angle, okay, what I'm going to do is, let me first find the angle here. Then I'm going to subtract it from 360, because if I do the complete circle, it will be equal to 360. So to find the angle here, now remember, there was a point which I said, if you have a north pole here and another north, it means the angle that you have here and the angle that you have here, they should add up to 180. I don't know if you recall, I can go back. This is the point that I'm looking at. So I said if you have a north here and a north here, it means this angle and this angle should add up to 180 degrees. So we come back to the question. So now we have seen that there is a north there and another north there. It means these two angles should add up to 180. So therefore I'll say 180 subtract 141, and I am going to get 39. So 39 degrees here. Now that we have found 39 degrees here, to find this total angle now, I'm going to say 360, because the complete circle is 360, then I subtract a 39 which is there. So 360 subtract a 39, we get 321 degrees. So 321 degrees is the 3-figure bearing for answer A. Okay, so the first one has been dealt with. We go to part B. We find the bearing of A from C. So you first go where C is. This is C. So you check, do we have a north at C? We don't have a north. The first thing is we create a north, an imaginary one. So this is the north at C that we've created. That is the north that we've created. Then I want you to know that the angle here, so let's first look at the bearing. The bearing of A from C. So this is the north of C. Then it goes and joins where A is. So this is the bearing we're looking for. How can we find that bearing? Now, it will be easier for us to find that bearing. We just have to find the angle here. If we can find the angle here, then we just subtract it from 180, then we found the bearing there. So now, what are we going to do? So what we're going to do is basically the following. Okay, so we know to say the 321 is this distance here. Let me show you. So this bearing, this angle is equal to 321. Then the one which is inside is 225. So if we say 321 subtract 225, then we're getting, that's the angle that is inside here. We're getting the angle inside here. So can you do 321 subtract 225? If you do the calculations, you should find 66. So you should find 66 degrees inside. Then this 66, now look at, we have a triangle here. This is a triangle. If you follow it, this side, this side, this side, and we said angles in a triangle add up to 180. So we need to find the angle here. So if we say 35 plus 66, then those two, we subtract them from 180. So in order for us to find this angle, so we add these two angles, the 35 and the 66, then we subtract them from 180. So if we say 35 plus 66, we get 101. Then when we say 101 subtract 180, or 180 subtract 101, we get 79. So here we have 79. Then finally, to find for this one now, we say, look at, if this is the complete circle, it will equal to 360. Then we can say 360, we subtract these two, so 141 plus 79, then these two. Now look at, if I say 141 plus 79, so those two will give me 220. Then that 220, I subtract it from 360, then I'm going to get here, I'm going to get 140. So I'll get 140. So 140 here, if this is 140, automatically this becomes 40 degrees, because these two should add up to 180. Then what I'm going to do now is to write this one now as a three-figured bearing. We just say 0, 4, 0, like that. So like that, it is written as a three-figure bearing. Hope you found this helpful. We're going to proceed to look at a different question that we can do that is going to be of help to us. So that one has been dealt with. So now we see another question that we can do on just on this same topic, bearing. All right. So the second example. We have an angle. So suppose we have the following. Okay. All right. So suppose we have that. So let's say, let me put up this. Suppose we have that and that. Okay, then we have that and that. Then we have north. So a north there, a north. Then let's say we have a 70 degrees there given us. Then they've given us 130 degrees there. Okay, I think just that. Then we can say this is A, that one is B, then that one is C. Then what we're going to do now is they're now asking us to find the bearing. So we can say find or calculate. So you can say find bearing. Find the bearing of, so the first one, so A, find the bearing of A from B. And the bearing of A from B. Then the second one, we find the bearing of B from C. So find the bearing of B from C. Okay then, so how are we going to go about those? So this is what we're going to do. So you go where it's saying from. So at B we already have a north. Then we move from B. We go all the way up to where the line is joining A. So we're looking for that distance. Now how can we find that distance? So to find that distance, we're going to say, so since I know this 70, if I add it with this angle, they should be equal to 180. So this angle here will be 180 minus 70. I get 110 degrees just for this angle. Then I know if I complete the circle, it will be equal to 360. So I'll say, what is 110 plus 130? So that one will be 240. Then I say 360 subtract 240, so that I'll be able to find for that other one. So now I want to find for this part only, for the part inside. Okay, so the part inside, or I can find the one which is remaining. Since I'm looking for this, let me just find it as the entire, as a whole. So this entire angle, so this one I can say 360. Let me just subtract the 110. So I'll say 360 subtract 110. So this is degrees. So what we get when you say 360 subtract 110, we get 250 degrees. So this is already a three-figured bearing. So that one has been dealt with. We go to the other one. So this is where C is. Then the bearing of B from C. Do we have a north at C? We don't have, so you create a north like that. After the north has been created, you move from C all the way to B, from C all the way to B. So we're looking for this bearing. How can we find that bearing? So to find that bearing now, what we're going to do is basically we're just going to find the angle here. So this gamma angle, then we subtract from 360. Now remember I said this angle here, so angles which are in this form, where we have a north and a north, these angles add up to 180. So if I say 180 minus 130, I get 50. So that is the 50 which is there. Then to find this one, I'll say 360 subtract 50 degrees. So 360 subtract 50 degrees, we get 310 degrees. So this is the three-figured bearing that we find. Now that that has been found, we're going to look at one last example. Then we see some other questions that we can do. So the last example will be as follows. All right. So this is the third question. Third example. So let's say, so suppose we have a diagram as follows. Alright, then if they've given us 159 degrees here, 159 degrees here, then we've also been given another angle here, let's say from here all the way to there. So this one, let's say this one they've given us as 215 degrees. Then we have another one, so let's say this one is from here to there. This one is 41 degrees. Then we can say this is y, that is x, then we have p there. So we can have that. Then the question now is saying find the bearing. So find the bearing of, so the first one, we find the bearing of x from y. The second one, we find the bearing of p from x. So that is what we have there. Then now, from there now, we can proceed with the solutions. So how are we going to go about it? We start with the first one, bearing of x from y. So this is where our y is. So do we have a north at y? We don't have. Draw a north. Then after you've drawn a north, then you start from y, you go where x is. So from y, this is the line that is connecting to x. So we're looking for that angle. How can we find that angle? To find this angle, we just have to find the small angle here, then we add it to 41. How can I find the small angle here? So this is what I'm going to do. I know to say this entire angle from this point to this point is 215. So I can just say to find the angle here, I'll say 360 subtract 215, and I'm going to get 145. So if I get 145 here, then to find the angle here, I'll say 180 subtract 145, and I get 35. So I have 35 degrees there. So to now get this bearing, I'm going to say 35 degrees plus 41 degrees. So I add these two together. So I get 76, but I'll put a 0 so that it becomes 076 degrees. So that is the bearing of X from Y. Then we go to the other one where they've asked us to find the bearing of P from X. So this is where X is. So do we have a north at X? We don't have. Draw a north. So the north, we've drawn it. Then we move from the north of X in the clockwise direction. Then we go to the line that is joining P. So this is the line that is joining P. So we're looking for that angle there. How can we find that angle? First things first, let us find the angle inside here. Now remember, if we have a north and we have another north there, it means the angle here, the 159, and the angle this should add up to 180. So if I say 180 minus 159, we are getting 21. So there is a 21 degrees here. To now get this bearing we are looking for, I'll say 360, then subtract 21 degrees. So what is 360 subtract 21? We get 339 degrees. So this is the 3-figure bearing that we found. So that is how best we can go about that. Then that is done. We'll now look at some questions that you can try. I'll just give 2 questions as that will serve as a task. Right, so we have a task here. Alright, so the first question, I'll give you a question that will contain angles. So I'll give you a question that will contain some angles. So let's say, just a minute, I want to check what we had here. We had that. Alright, so I'll give you a question that will contain some angles, then the other one will just be on bearings. So this is the first question. Suppose you have a diagram as follows. So this is a diagram that you have, then it is coming like that, then it is coming like that, then we have a north that is going in that direction. So we have a north there, then we have an angle there that is 216. So 216 degrees. So we can say this is W. Then we have that, another north there. Then we have Z there. Then suppose I give you, there is P here. Then I say from here all the way up to there. So I say it is 296 degrees. So 296 degrees. Alright. Just those I think will be able to help. Then now what I want you to find is the following. So let's say calculate A. You calculate the angle. So here you're calculating angles. So PWZ. So you're calculating the angle at W. The second one, you find the angle at P, so WPZ, so you find that. So this question, now remember this question is on angles, so you're finding the angles. Then the next question I'm giving you now is on bearings, so that you'll be able to find the bearing. Okay, so let's look at the second question. So second question, we have a diagram. Suppose we have a diagram as such. So we have something like that, something like that. So suppose we have 128 degrees like that, then we have 62 degrees like that. So this was the north. Then we have, this is point B, then this is point A, then we say this is point C that we have there. Then if that is okay, so from there, so we've been given a 128 there, we have 62 there. Then now let's say, what do they want us to find? So let's say, suppose you find bearings now. So find the bearing. Find the bearing of A, C from B. Then the second one, find the bearing of A from C. So just these two, I think they'll be enough. These will serve as an exercise, so try out those using the examples, then we see how best you can go about them.